is Muhammad Fitri Iman bin Fauzi, and I will be presenting my thesis, which entitled An Efficiency Comparison Between Monocrystalline and Polycrystalline Solar Panel at UiTM Jengka. Solar energy is renewable and free for all on this planet because it comes from our sun. The supply is also limitless and it produces no pollution. So, solar energy is predicted to become a popular energy source in the 21st century than the finite fossil fuel coals, petroleum, and natural gas. The first problem statement is Malaysia's tropical weather, where it's sometimes cloudy and it will limit the amount of sunlight that hit the solar panel. Secondly, higher production cost for monocrystalline solar panel that will make it expensive than the polycrystalline solar panel. Objective of this study to compare the efficiency between monocrystalline and polycrystalline solar panel, and also to identify the pros and cons of monocrystalline and polycrystalline solar panels. The first research paper evaluate the performance of monocrystalline solar panels. They use 6 monocrystalline solar panels to find the efficiency, and they get the efficiency range from 9.44 to 10.56%. They also compare the manufacturer specification of the solar panel with the real operating specification, and they found out it's not the same, which the real operating specification is lower than the manufacturer's specification. The method that we use in the paper is they change the resistance to obtain the IV curve, and then they measured the I and V using the multimeter. I found out this method is simple and easy, and we use it in our study. The second paper is to compare the performance of monocrystalline and polycrystalline using the single diode model. Their finding is that the monocrystalline solar panel produce electrical output power of 9.55 watt, and for polycrystalline solar panel is 9.722, which is monocrystalline power produced is higher. The method used in this paper is single diode model, and they also produce 5 parameters such as light current, diode reverse saturation current, diode ideality factor, series resistance, and shunt resistance. The last paper also investigate the performance of the monocrystalline and polycrystalline solar panel, but the glass base. The output from the fabricated polycrystalline were 67.4 watt, while the monocrystalline 75.67 watt. Monocrystalline output is higher. Then the electrical efficiency of the two PV panels were analyzed to be 10.54% and 12.23%. This means that this paper also found out that monocrystalline efficiency is higher than the polycrystalline solar panel. In this paper, they used an IV tracer to trace the reading of the electrical characteristic, which is current and voltage of the solar panel. It is easy as they use the collected data and put it into a PC and analyze it. The first methodology is to set up the circuit as shown in the figure, and then we measure the open circuit VOC and the short circuit current ISC of each solar panel. and then we change the resistance value of the power resistor and record value of the I and V, and then we can calculate the power of the solar panel. After that, we plot the graph of IV and PV. From the graph of PV and IV, we can obtain Vmax, Imax, and Pmax, and then we can calculate the P factor and the efficiency of solar panel. Lastly, we can compare both solar panels. When we obtain the value of the voltage and current, we can calculate the power produced by both solar panels using the equation P equal to IV. This is the IV curve for both solar panels. We can see that the polycrystalline produce higher voltage, while the monocrystalline produce higher current. This is the PV curve of both solar panel. From this curve, we can find the Pmax and Vmax. The point where it is located is at the highest point of the graph. So we will get the Vmax and Pmax, and then we can find Imax. This is the Imax, Vmax, and Pmax value obtained from the graph. It also can be calculated using the equation P max equal to I max times V max. Next is the phi factor. Using the equation, we found that the phi factor for polycrystalline solar panel is higher than the monocrystalline solar panel. Last but not least, we calculate the efficiency of the solar panel using the equation maximum power over solar irradiance times the surface area of the solar panel. We get polycrystalline efficiency is 15.79% and monocrystalline 16.48%. In conclusion, the efficiency of monocrystalline solar panel is higher than the efficiency of polycrystalline solar panel. It is due to the advanced technology used to produce the monocrystalline solar cell with single layer of pure silicon. So it becomes expensive. Meanwhile, polycrystalline solar panel is less efficient but cheaper to produce with its raw multi-silicon structure.